Hello everybody, and welcome to part 3 of my video series on Plantinga's modal ontological argument. Links to parts 1 and 2 of the series are below, and you should probably have seen at least part 1 of this series before watching this one. In part 1 of the series, we said that Plantinga's modal ontological argument is an ontological argument given within a formal axiomatic system called S5 modal logic. So in this part of the series, we are going to study S5 modal logic and its relationship to the modal ontological argument. Now, S5 modal logic is built on top of S4 modal logic. S4 modal logic is built on top of modal logic, and modal logic is built on top of propositional logic. So to start with, we're going to discuss propositional logic. In propositional logic, we deal with propositions, which are also called statements. Loosely speaking, a proposition is an assertion that must be either true or false, but cannot be both. Examples of propositions include, unicorns exist, my dog has fleas, it's raining outside. If P is a proposition, the negation of P, called not P, is the proposition with the opposite truth value as P. So that means if P is false, then the proposition not P is true, and if P is true, then the proposition not P is false. So for example, the negation of unicorns exist would be no unicorns exist, or equivalently, unicorns do not exist. Two propositions are logically equivalent if we can show, using logical reasoning and unwinding definitions alone, that they must have the same truth value, either both true or both false. For example, Jim is a bachelor and Jim is an unmarried bachelor are logically equivalent because the definition of bachelor includes being unmarried. These two propositions either have to both be true together or both be false together. If P is any proposition, then P and not P are logically equivalent. For example, so if P is true, then not P is true, and if P is false, then not P is false. Logically equivalent propositions are in a sense equal as far as propositional logic is concerned. They are interchangeable in arguments. To demonstrate one is true is to demonstrate the other is true. Anything that can be proven using one can be proven by using the other. If P and Q are two propositions, then the assertion if P then Q is called a conditional, and it is true if and only if it cannot be the case both that P is true and Q is false. So for example, if Jim is married, then he is not a bachelor, is an example of a true conditional, because it is logically impossible that Jim could be both married and a bachelor. If I will jump into the pool, then I will get wet, is another example of a true conditional, because it is physically impossible that I will both jump into the pool and I will avoid getting wet. There are different kinds of conditionals corresponding to different kinds of impossibility. Our first example here was a logical conditional. Our second example was a physical conditional. There are also metaphysical conditionals. However, in the modal ontological argument, at least in this video series, we are only going to be interested in logical conditionals. Now, the contrapositive of the conditional if P then Q is the conditional if not Q then not P. Notice that we reverse the order of the P and the Q and we put nots in front of both of them. If P then Q means that it cannot be the case that P is true and Q is false. If not Q then not P means that it cannot be the case that not Q is true and not P is false. But that means the same thing as saying it cannot be the case that P is true and Q is false. So a conditional and its contrapositive are logically equivalent. As far as propositional logic is concerned, they are interchangeable. An example of this is the contrapositive of if Jim is married, then Jim is not a bachelor is if Jim is not a bachelor, which is the same thing as saying if Jim is a bachelor, then Jim is not married. These propositions are logically equivalent. As far as propositional logic is concerned, they are interchangeable. Because they are logically equivalent, they must be both true or both be false, and in this case, they are both true. They both mean it cannot be the case that Jim is married and Jim is a bachelor. In addition, the propositions if P then Q and P only if Q are logically equivalent. P only if Q means that it cannot be the case that P is true and Q is false, because P can be true only if Q is true. So, for example, the propositions if Jim is a bachelor, then Jim is not married, and Jim can be a bachelor only if Jim is not married, are logically equivalent. Now consider the propositions, if I will jump into the pool, then I will get wet. It's contrapositive. If I will not get wet, then I will not jump into the pool. And the only if version, I will jump into the pool only if I will get wet. These are all logically equivalent. As far as propositional logic is concerned, they all mean the same thing. They all mean it can't both be true that I will jump into the pool and false that I will get wet. However, despite that, I don't think they feel the same. If I look at the first conditional, it makes sense. If I will jump into the pool, then I will get wet. Well, because the pool is full of water, so of course. But when I read the second two, they sound a little weird. If I will not get wet, then I will not jump into the pool. I will jump into the pool only if I will get wet. In the second two, it's kind of sounding like I'm making the decision not to jump into the pool unless I get wet. What's going on here? Well, in informal speech, when we say if P then Q, we usually mean to imply that P happening in some sense causes Q to happen or leads Q to Q happening. We usually mean this to say that if P happens, then Q will happen because P happens. And if P and Q occur in time, we usually mean to imply that P comes before Q in time. But propositional logic does not deal with causality or time. It is only concerned with the logical relations of the truth of various propositions. So, as a result of this, when analyzing a conditional proposition, it can be helpful to look at its contrapositive. Even though the contrapositive will be logically equivalent to the proposition, sometimes some things may appear to be more intuitive in one form of the conditional than in the other. So that's propositional logic. Now, modal logic builds on top of propositional logic. In modal logic, in addition to being true or false, now every proposition is either necessary or contingent, but not both. That leads to 4 combinations for propositions. Propositions can be necessarily true, such as 2 plus 2 equals 4. They can be contingently true, such as horses exist. They can be contingently false, such as unicorns exist. Or they can be necessarily false, such as 2 plus 2 equals 5. Necessarily false propositions are called impossible propositions, and a proposition is possibly true if and only if it is not necessarily false, that is, not impossible. There are many different axiom systems for modal logic. Each axiom system consists of a different set of axioms for reasoning about possibility and necessity, and each axiom system is designed to model a different type of possibility and necessity. In this video series, we are only going to be concerned with 2 modal axiom systems, S4 modal logic and S5 modal logic. We begin with S4 modal logic. S4 modal logic is meant to model apodictic modality, which we discussed in part 1. It is the logic of provability, demonstrability. It is an epistemic modality of what in principle can be known. S4 modal logic has actually been used in the study of mathematics to study provability. For example, it's been used in a proof that the continuum hypothesis cannot be proven true or false using the other axioms of set theory. I'll put a reference to a book on this in the description below. Some axioms of S4 modal logic include, if a proposition is necessarily true, then it is true. That makes sense in a logic of provability. If I prove a proposition is true, then that proposition had better be true. It also makes sense in a logic for classical philosophical ideas about the nature of knowledge. Classically, philosophers have assumed that if we say so and so knows such and such is true, then such and such is actually true. Another example is, a proposition is not necessarily false if and only if it is possibly true. This one actually is not special to S4 modal logic. S4 modal logic inherits this from kind of generic modal logic. If you think about it, it makes sense. Another axiom is, if a proposition is necessarily true, then it is necessarily true, it is necessarily true. Again, this makes sense in a logic of provability. If I prove that a proposition is true, then not only have I proven that that proposition is true, but by doing that, I've also proven that I can prove that proposition is true. And this also makes sense in a logic for classical ideas of knowledge. Classically, philosophers have assumed that if we know something is true, then we also know that we know that it is true. So this is not a complete list of axioms from S4, although it does include the two big axioms that S4 adds to kind of generic modal logic, but this is not meant to be exhaustive. Well, now let's go on to S5 modal logic. To introduce S5 modal logic, we are going to explore a question. In modal logic, a proposition can be both true and possibly false. For example, the proposition horses exist is both true and possibly false. If we're speaking metaphysically, this would mean that it is true horses exist, but there is a way the world could have been such that horses wouldn't have existed if the world had been that way. But could a proposition be both true and not just possibly false, but possibly impossible? For example, could it be the case that horses exist, and yet it is impossible horses exist? If we're speaking metaphysically, that would mean, could there be a way, even though horses exist, could there be a way the world could have been such that not only would horses not have existed if the world had been that way, but it would have been impossible horses could have ever existed if the world had been that way? So that's the question. Okay, so S5 answers this question no. S5 modal logic starts with S4 modal logic, so that every axiom of S4 modal logic is also an axiom of S5 modal logic, and then it assumes an additional axiom. If a proposition is true, then it is not possible that proposition is impossible. So in the cases of horses, since it's true horses exist, it is not possible that it is impossible horses exist. An equivalent way to put this is, if a proposition is true, then it is necessarily true that that proposition is at least possibly true. So if a proposition is true, then it is necessarily true that that proposition is possibly true. Now, this axiom does not make sense in an apodictic modality, an epistemic modality of provability, where saying something is necessarily true means it can be proven to be true. Just because a proposition is true doesn't necessarily mean we will be able to prove it is possibly true. Even if it's true, we might not know it's true, and we might not be able to know it's true, and we might have no way to prove it's not impossible. So this axiom is not appropriate for a modality of provability, and that's why we did not add this axiom to S4 modal logic. That's why we're only adding it now to S5 modal logic. This axiom only makes sense in a metaphysical modality, a modality about what is necessarily true, not about what can be proven to be necessarily true. So according to S5, if a proposition is true, then it is necessarily true that it is possible it is true, regardless if anyone is able to prove it is possibly true or not. So, if a proposition is true, it is not possible that it is impossible, it is true. Let's take this axiom and restate it in logically equivalent forms. To begin with, we'll replace a proposition with its negation. So this becomes, if a proposition is false, then it is not possible that it is impossible that proposition is false. Okay, so saying that it is impossible a proposition is false is the same thing as saying it's necessarily true. So this is the same thing as saying if a proposition is false, it is not possible that that proposition is necessarily true. Well, that makes sense. If a proposition is false, then it is not possible that proposition is necessarily true. So for example, unicorns don't exist. So from that alone, we know it's not possible it could ever be necessarily true. Unicorns exist. Taking the contrapositive gives, if it is possible a proposition is necessarily true, then it is true. So if it is possible a proposition is necessarily true, then it is true. This is the form of the axiom we will need for the modal ontological argument. And in this form, the axiom may perhaps appear to be counterintuitive. Wait, just because it's possible a proposition is necessarily true, somehow magically that means the proposition is true? How does that work? Well, remember, we are no longer working in an epistemic modality where saying something is possibly true means that it cannot be proven false. This does not say that a proposition must be true just because we can't prove it is not necessarily true. This axiom is perhaps best understood in its only if form. It can be possible a proposition is necessarily true only if it is true. So what this says is we're no longer working in an epistemic modality where we can assume it's possible a proposition is necessarily true just because we can't prove otherwise. This says, working in S5, if we want to demonstrate it is possible a proposition is necessarily true, at the very least we have to demonstrate it is true. So if it is possible a proposition is necessarily true, then it is true. By combining this axiom with the other axioms that S5 modal logic inherits from S4 modal logic, we can demonstrate a stronger version of this axiom is true that also has to be true in S5 modal logic. We will not need this stronger version of the axiom for the modal ontological argument, but we will include it here for completeness and also to help better understand S5 modal logic. So if it is possible a proposition is necessarily true, then not only must that proposition be true, but that proposition must be necessarily true. So if it is possible a proposition is necessarily true, then it is necessarily true. Now, this, if anything, is even more surprising than the previous version. And when I first saw this, I thought it was very confusing. What? Just because it's possible a proposition is necessarily true, somehow, magically, it follows that the proposition actually is necessarily true? How does that work? Well, the first thing to remember is that we're not working in an epistemic modality any longer. And this doesn't mean a proposition is necessarily true if we can't prove it isn't. That would be ridiculous, and that's what this would mean if we were working in an epistemic modality. What this axiom actually means is that working in S5, if we wish to demonstrate it's possible a proposition is necessarily true, we have to demonstrate it's necessarily true. Working in S5, if P is a proposition, it makes no sense to say, I'm not saying P is necessarily true, I'm just saying it's possible P is necessarily true. There's no such thing as just saying it's possible P is necessarily true. If we say it's possible P is necessarily true, we are saying P is necessarily true. In S5, it cannot be contingently possible that a proposition is necessarily true. Another way to put this, and I think this is what's going on at a deep level, is that working in S5, whether a proposition is necessarily true or not, is itself something that does not depend upon the condition of the world. Okay, so that's S5 modal logic. Okay, so let's go on to the modal ontological argument. We have a new version of the modal ontological argument that takes advantage of what we've studied about S5 modal logic. So premise 1, it is possible a maximally great being exists. Premise 2, if it is possible a maximally great being exists, then it is possible it is necessarily true a maximally great being exists. Premise 3, if it is possible it is necessarily true a maximally great being exists, then a maximally great being exists. Conclusion, a maximally great being exists. Okay, so we defined the term maximally great being in the first video in this series, but let's review that just in case anyone's forgotten or didn't watch the first video. First of all, a maximally excellent being, MEB, is a being that is omniscient, omnipotent, and perfectly good, omnibenevolent. So a maximally great being, MGB, is a being that necessarily exists and is necessarily a maximally excellent being. That's the definition. So every premise in this argument is referring to metaphysical possibility and necessity. The first premise is saying it is metaphysically possible a maximally great being exists. The second premise is saying if it is metaphysically possible a maximally great being exists, then it is metaphysically possible, it is metaphysically necessarily true a maximally great being exists. And the third premise is saying if it is metaphysically possible, it is metaphysically necessarily true a maximally great being exists, then a maximally great being exists. Now, I don't want to have to say the word metaphysically over and over again, just like I did there. So from now on, just bear in mind that every premise in this argument is referring to metaphysical possibility and metaphysical necessity. So this is my favorite form of the modal ontological argument. The reason for that is every premise of the argument neatly separates out one of the significant assumptions the modal ontological arguments makes. The second premise depends upon the definition of a maximally great being. It can't be possible a maximally great being exists unless it is possible it is necessarily true a maximally great being exists, because a maximally great being is defined to be a necessary being. So existing necessarily is one of the required properties a being must have to be a maximally great being. Premise 3 depends upon the axiom system S5. In S5, in order for it to be possible a proposition is necessarily true, the proposition must at least be true. So in order for it to be possible that the proposition a maximally great being exists is necessarily true, the proposition a maximally great being exists must be true. Finally, this argument is valid. The first it's of the form premise 1 P, premise 2 if P then Q, premise 3 if Q then R, therefore R. So the conclusion follows from the premises. And of course the challenge is justifying premise 1. As always, the challenge is showing that it is possible a maximally great being exists. So let's proceed by expressing this argument in a different form. Let's start by reversing the order of the premises, swapping the first and third premises. So the first premise, it is possible a maximally great being exists, will become the third premise, and the third premise will become the first premise. So now let's take the contrapositive of the first two premises. Remember that the contrapositive of if A then B is if not B then not A. Conditional is always logically equivalent to its contrapositive. So if it is possible, it is necessarily true a maximally great being exists, then a maximally great being exists, that's premise 1. The contrapositive of that is if no maximally great being exists, then it is not possible it is necessarily true a maximally great being exists. The second premise, if it is possible a maximally great being exists, then it is possible it is necessarily true a maximally great being exists. That will become, if it is not possible it is necessarily true a maximally great being exists, then it is not possible a maximally great being exists. So finally, Let's change the wording of the premises slightly. This will have no effect on the argument except hopefully to make it read better, to make the argument read more smoothly. So the first premise, if no maximally great being exists, then it is not possible it is necessarily true a maximally great being exists. Let's rephrase this slightly as, if no maximally great being existed, then it would not be possible it is necessarily true a maximally great being exists. For the second premise, if it is not possible it is necessarily true a maximally great being exists, then it is not possible a maximally great being exists. Let's rephrase that slightly as, if it were not possible it is necessarily true a maximally great being exists, then it would not be possible a maximally great being exists. For the final premise, premise 3, it is possible a maximally great being exists. Let's rephrase that as, but it is possible a maximally great being exists. Okay. So this is still the modal ontological argument. Every premise of this argument is logically equivalent to a premise of the original. The justification for each premise is the same as for the corresponding premise in the original. The conclusion is the same. It is just expressed differently in the form of what mathematicians call a proof by contradiction. What this argument is now saying is, well, a maximally great being has to exist. After all, if no maximally great being existed, it wouldn't be possible it's necessarily true a maximally great being exists. And if it wasn't possible it is necessarily true a maximally great being exists, it wouldn't be possible a maximally great being exists at all. But that's ridiculous. Of course it's possible a maximally great being exists. So therefore, a maximally great being exists. So this argument is valid. Really, it has to be valid because it's equivalent to our original argument, but let's check it separately anyways. The form of this argument is premise 1, if not P, then not Q. Premise 2, if not Q, then not R. Premise 3, R. Therefore, conclusion, P. So what this is saying is, if we see P is false, that leads to the conclusion that R is false, but we know R is true, therefore P must be true, because assuming that P is false leads to a false conclusion. And again, that's a proof by contradiction. So we know premise 1 is true because it is an example of an axiom from S5. If no maximally great being existed, if a proposition is false, then it cannot be possible it is necessarily true. So if no maximally great being existed, then it would not be possible it is necessarily true a maximally great being exists. Premise 2 follows from the definition of a maximally great being as a necessary being. A maximally great being is defined as being necessary, so if it were not possible it is necessarily true a maximally great being exists, then it would not be possible a maximally great being exists at all. But why should we grant premise 3 of the argument? Why should we grant it is possible a maximally great being exists? Again, every time we analyze this argument, we come to the same place. Well, what are some reasons people have proposed for supporting the premise that it is possible a maximally great being exists? Some have argued we ought to grant it is possible a maximally great being exists because the definition of a maximally great being seems coherent, in the sense that it doesn't seem possible to derive a contradiction from the definition of a maximally great being. Some people have also argued that even if we don't accept that, the modal ontological argument still places an additional burden on the atheist. They argue that because if no maximally great being exists, then it is impossible a maximally great being exists, it is no longer sufficient for the atheist to argue that no omniscient, omnipotent, omnibenevolent being exists. Now the atheist must prove it is impossible a maximally great being exists. Just to be clear, if you read his book, The Nature of Necessity, Plantinga himself never made either of these arguments, and I don't want to give the impression that he did. He knew better than that. In my opinion, Plantinga did a brilliant job writing his modal ontological argument, and I'm here addressing what I think are mistakes others have made in interpreting it, so I don't want anyone to get the wrong idea. Okay, so the problem with both of these arguments is that the modal ontological argument does not show that if no maxillary being exists, then the definition of a maxillary being will no longer be coherent in the sense described above. It does not show that if no maxillary being exists, then it will be possible for atheists, or anyone else for that matter, to prove it is impossible a maxillary being exists. These are forms of epistemic impossibility, of what can be proven to be false, of propositions where we can derive a contradiction by unwinding definitions and using logic alone. The modal ontological argument only shows that if no maxillary being exists, then it will be metaphysically impossible a maxillary being exists, not epistemically impossible. The modal ontological argument shows that if no maxillary being exists, then it will be metaphysically impossible a maxillary being exists, not because the definition of a maxillary being will then somehow be epistemically incoherent, not because it will then be possible to derive a contradiction from the definition of a maxillary being, but purely because A, no maxillary being exists, B, we've defined a maxillary being to be a necessary being, so it can't be possible a maxillary being exists unless it is possible it is necessarily true a maxillary being exists. And C, we're working in S5, where it can't be possible it's necessarily true a maxillary being exists unless a maxillary being actually exists. So boiling all that down, given our definition of a maxillary being, and given that we are working in S5, if no maxillary being exists, then it will be metaphysically impossible a maximally great being exists purely because no maximally great being exists. Because logically, it cannot both be the case that A, no maximally great being exists, and yet B, it is metaphysically possible, it is necessarily true, a maximally great being exists. This will be true whether it is epistemically possible a maximally great being exists or not. So now let's go back to our two proposals for supporting the possibility premise of the modal ontological argument. Suppose we can demonstrate the proposition a maxillary being exists is perfectly coherent in the sense that it is impossible to derive a contradiction from it. Can we then conclude from the modal ontological argument that a maxillary being exists? No, we cannot. There is nothing in the modal ontological argument that says if no maxillary being exists, the proposition a maxillary being exists will be incoherent in the above sense. Given the way we have defined our terms and the axiom system we have chosen to work in, if no maxillary being exists, whether or not anyone can know or prove no maxillary being exists, it will be metaphysically impossible a maxillary being exists purely because no maxillary being exists. There is nothing in the modal ontological argument to suggest that it can't both be true that A, the definition of a maxillary being is perfectly coherent as described above, and B, at the same time, no maxillary being exists, and so it's metaphysically impossible a maxillary being exists. There's no contradiction, logical contradiction, given the definitions and the axiom system S5 of the argument between A and B. And so therefore, even if we were able to establish the definition of a maxillary being as perfectly coherent as described above, it would not follow from that alone that a maxillary being exists. So what about the second attempt? Does the modal ontological argument place an additional burden on the atheist to prove it is impossible a maxillary being exists if they wish to argue no omniscient, omnipotent, omnibenevolent being exists? And the answer is no. The modal ontological argument places no addition, the ontological argument places no additional burden on the atheist or anyone else. There is nothing in the modal ontological argument that says, if no omniscient, omnipotent, omnibenevolent being exists, then the atheist or anyone else will be able to prove it is impossible or demonstrate it is impossible a max great being exists. Working in S5, and given how we have defined our terms, if no omniscient, omnipotent, omnibenevolent being exists, then whether or not it is possible for the atheist to prove no max great being exists, it will be metaphysically impossible a max great being exists purely because no max great being exists, and because of the way we've defined our terms and because we're working in S5. There is nothing in the modal ontological argument to suggest that it can't both be true that A, it is not possible to prove no max great being exists, and yet B, at the same time, no omniscient, omnipotent, omnibenevolent entity exists. So even if somehow we were able to establish it is not possible to prove no max great being exists, it would not follow that an omniscient, omnipotent, omnibenevolent being must exist. And so that's basically it. Even if the definition of a max great being is epistemically coherent, that doesn't mean a max great being exists. And even if no one can prove no max great being exists, that doesn't mean a max great being exists. And I'd like to point out that these two results, although it took a lot of work to get to them, are really quite obvious. They're really quite obvious. They are common sense. Of course, just because the definition of a max great being is internally coherent purely as a definition, it doesn't follow from that a max great being must exist and couldn't possibly not exist. That doesn't make any sense. Verifying a definition is epistemically coherent is kind of the least requirement we could give. Of course, it has to be epistemically coherent before we even begin to see whether an example of that entity exists. So it is ridiculous to assert that if the definition of a max great being is epistemically coherent, we can't draw a contradiction from it, that somehow that means, then a max great being must exist and couldn't possibly not exist. That doesn't make any sense. In the same way, if no one can prove no max great being exists, that doesn't mean a max great being exists. Of course not. Just because we can't prove no max great being exists, that doesn't mean that therefore max great being exists and has to exist necessarily and couldn't possibly not exist. And again, that is ridiculous. And again, the modal ontological argument doesn't say either of these propositions. What happens here, what confuses people, is the modal ontological argument works only in a metaphysical modality, using metaphysical possibility and necessity and impossibility. And what people do is, because they're not familiar with that, they take their intuitions about epistemic possibility and necessity and apply it to the modal ontological argument. But that just leads to nonsensical results. When people first hear from the MOA that if it is possible a max great being exists, then a maximally great being exists, they typically say to themselves, wait, that can't be true. That doesn't make any sense. Just because it's possible a max great being exists, then a max great being exists and couldn't possibly not exist? That makes no sense. That's usually people's first reaction. And they are right. That isn't true if we are interpreting possibility as epistemic possibility, which is what we typically do in normal usage. This statement is only true once we learn about metaphysical possibility and necessity. But then it doesn't say what some people think it does. It doesn't mean that just because the definition of a max great being is internally coherent in the sense that it is impossible to derive a contradiction from it, it doesn't mean if that's true, then a maximally great being has to exist and couldn't possibly exist. And quite frankly, that's just a nonsensical assertion. Okay, so it took me about a year after I first heard Plantinga's modal ontological argument before I felt I understood it well enough to explain why it was unconventional. I had to do a lot of study about what metaphysical and epistemic possibility and necessity were about, and I had to do a lot of study and a lot of thinking about it before it all really made sense to me. Nevertheless, the first day I learned about the argument, I was convinced it couldn't possibly work. Why is that? Well, the reason for that is Plantinga's modal ontological argument is presented using formal logic. And in formal logic, there is no such thing as a free lunch. What do I mean by that? Well, what I mean by that is that formal logic gives us tools to organize our reasoning, but those tools are themselves empty of content. If we introduce substantive assumptions as premises, formal logic can tell us what follows from those premises. But we cannot prove anything substantive from the rules of formal logic and from definitions alone. We can't even prove a cup of coffee exists using formal logic and definitions alone, let alone that God as the supreme being exists. That's just not what formal logic is good for. You see, reality exists before our attempts to reason about it. Reality exists before we define our terms, choose our logical axioms, and deduce our conclusions. Our propositions will be true or false depending on the nature of reality. But the reverse is not the case. Reality will not conform itself to accommodate our beliefs about our propositions. And this is why I do not believe any ontological argument can possibly work. Applying all this to the modal ontological argument in particular, if in reality God exists as a maximal great being, then according to the assumptions we have made in the modal ontological argument, it will be possible a maximal great being exists. On the other hand, if in reality no maximal great being exists, then according to the assumptions and definitions we have made, it will not be possible a maximal great being exists. And that is all we can say. Reality precedes our attempts to reason about it. Reality is not going to adjust itself just because we have chosen our axioms and defined our terms in such a way that it is impossible maximal great being exists becomes a logical consequence of no maximal great being exists. Reality doesn't care. Reality doesn't care about the definitions and axioms we make. And that is why, whether a maximal great being exists or not, whether the modal ontological argument is sound or not, the modal ontological argument fails as an argument to rationally justify a belief in God. Okay, so thank you all very much for sitting through all that. I hope it was helpful or at least entertaining. Thank you all very much.